Art. Perfect. Oh, sure. I'll just quickly revise the entire chapter, see what we studied, whatever we completed before starting the sum solving. So the chapter was Unit 1, Chapter 2, which is the discrete approach to pricing, or also known as the binomial model. This was the first chapter or the first attempt towards building an option valuation model. The main assumption, or rather the main critic of this entire chapter, was that the entire chapter is under a discrete process. It assumes that the underlying asset price or underlying ST actually follows a discrete process or a binomial model in that particular scenario. So we broadly had three parts to the approaches, or the three approaches to the model. The first approach was the replicating portfolio approach. The second approach was the risk neutral probability approach. So, under replicating portfolio approach, it uses the arbitrage based pricing approach. We understood that the limitation with the approach is that we have to solve the simultaneous equation at every nodes. Hence, as the time nodes increased, my computation became more tedious and more mathematically intensive. Hence, we've stuck to our expectation-based pricing approach, which is according to the first principles, your payoff into probability into present value, which is nothing but your risk neutral probability approach. In risk neutral probability approach, we first started looking at the non-recombining model, wherein the values of up move and the down move across your binomial model is not constant. We realized there as well that as the number of time step increased, the number of outcomes were way significant, which is 2 raised to n. Hence, we transitioned towards a recombining model, wherein we said that the value of u and d will stay constant throughout my entire binomial model, because of which my middle values are going to converge. Hence, the number of outcomes now that I have are n plus 1, and became very easy to solve because I can directly go from maturity to time 0 in the case of a European option, and an American call option in the case of non-dividend paying, because I know it behaves exactly like the European call option. For an American option, however, for an American put, I will have to still go from maturity to one time step back. Reason being, at intermediate nodes, I need to evaluate whether exercising my option is beneficial or letting my option run is going to be beneficial. So you take whatever is the higher value. Post that, we started with the full normal model. The purpose of full normal model was not to give you an option valuation technique or an option valuation approach. Here, what we did is we also did the continuous version of the model. We did the assumption that you will know the distribution. We'll prove it in a later chapter. But we did the distribution of log of ST by S0 follows normal distribution with certain parameters. We said that for me to get the answer the same under discrete approach and continuous approach, the mean of the parameters, the mean of the distribution under both approaches and the variance of the distribution under both approaches has to be the same. From here, we derive the distribution of U and D. And finally, we had the third approach, which is the state price deflator approach, wherein we said that I have the real world probability introduced. I have the real world probability introduced. We will come in over here with a modified discount factor, which we also called as the state price deflator. Started with looking at the assumptions. We also have the sum to do the state price deflator. Started with the assumptions of the binomial model. First assumption was assuming that the underlying process follows binomial distribution or the binomial model. It can be one step. If I evaluate at one time period, if I evaluate at more than one time period, I have accordingly a multiple time step binomial model. After that, whatever assumptions you have are fairly standard for any financial market theory. The debt accumulates at the risk-free rate of return. Basically, you can accumulate and discount using R, no taxes, transaction costs, so on and so forth, the other assumptions that we have. Then we looked at the replicating portfolio approach, wherein we used first, or the steps were, first you should know the binomial tree. Second, once you have the binomial tree, plot your payoffs at maturity depending on whether it's a call or put. Construct the replicating portfolio approach using phi quantities of underlying and psi quantity of cash. Solve your simultaneous equations, get the value of phi and psi, bring it one time step back, and then finally calculate the price at time 0. Realize the limitations, went to the risk neutral probability approach, wherein we first derived the equation of Q, which is nothing but e raised to r minus d upon u minus d. That's the equation that we derived over here. Then The way you solved it is you construct your binomial tree, plot your payoffs, calculate your values of probability, bring it one time step back depending on payoff into probability into PV factor. Realize the issue again over here that as the number of time steps increased, my number of outcomes become 2 raised to n. Hence, took the value of u and d to be constant for the entire binomial model. Repeated the same algorithm from maturity to time zero over here. Saw it for the American option, wherein in the case of American option, I evaluated where it's going to be beneficial. So here at intermediate node, which is 142 and 107, one value I have which I brought from the future, which is your red value. The other value that I'll have is if I exercise at these two time periods, what is going to be the payoff? Whichever is the higher payoff, you consider that as the payoff to bring it at 127. Just calculated or brought a comparison between risk neutral and real world probability. The takeaways over here are under the risk neutral probability, your underlying asset grows at the risk free rate. You know, real world probability is greater than the risk neutral probability. And whenever you are asked to check for no arbitrage in the market, you ideally need to test for the condition that D is less than E raised to R, which is less than U. How did we come to your risk? From the equation of the equality of risk neutral probability. And then finally, the equations of full normal model or state price deflator I'll do from start. But the equation of full normal model, wherein I equated the mean, I equated the variance, and I essentially come out to my equation U is equal to E raised to sigma root dt. And we had the assumption that D is equal to 1 by U. Hence, you have the equation of D as well. Any doubts to clear? In any concept of the chapter? Comfortable?
Yeah, all good.
Perfect. All right. We had done the concept of state price deflator. We are left with the sum. Let me start with the concept from scratch quickly, just so that it's fresh again. Now, the third approach that we had started with is nothing but the state price deflator approach. Now, academically, it's still an option valuation model that's there. But practically, this approach may sometimes be used to get this value of the real world probability in case you don't have enough data available with you. Now, what did we do over here? I know S0 goes up to US0, S0 comes down to DS0. Let's say the payoff at up move is CU, the payoff at down move is CD. I know C0, which is the option value at time 0, is essentially equal to CU into Q plus CD into 1 minus Q into present value factor, which is payoff into probabilities into PV factor. Now what I do is, wherever I have the risk neutral probability, whatever is the value, I multiply and divide the same factor, but instead of risk neutral, I now use the real world probability. So wherever I have Q, I multiply and divide by P and P. Wherever I had 1 minus Q, I multiplied by 1 minus P and divided by 1 minus P. In case you have something like Q into 1 minus Q, there you will multiply and divide by P into 1 minus P by P into 1 minus P. This will ideally be for an up move and then a down move. Because you are multiplying the probability of up move, you are multiplying the probability of down move. Now, what I do is, I multiply the e raised to minus r inside. So I have Cu into Q by P into e raised to minus r into P plus CD into 1 minus Q upon 1 minus P into e raised to minus r into 1 minus P. Now, if you look, you have your payoff, you have your probability. You have your payoff, you have your probability. What is remaining is the PV factor term, which is nothing but Q by P into e raised to minus r, 1 minus Q by 1 minus P into e raised to minus r, which I'll write it as AUAD, which is nothing but your state price deflator. The revised equation therefore becomes C0 is equal to CU into probability. So payoff into probability into state price deflator plus payoff into probability into state price deflator. Where state price deflator is nothing but risk neutral probability upon real world probability into your original PV factor. Payoff, or rather AU, is called as your state price deflator, but CU into AU will be called as your state price. So depending on what they ask in the question, you can calculate that accordingly. Any doubts in the approach?
Can you show the right side?
Can you show the
Right side, that equation.
right side? That's the equation of your state price deflator, which was essentially what? If I take the example, if AU The equation is Q by P into e raised to minus R, which is risk neutral by real world probability into PV.
And also the case where there is Q into 1 minus Q.
Q minus Q. Okay. So let's say if I have a two-step binomial model, 100 goes up to 110, comes down to let's say 90, goes let's say to 120. Let's assume U and D are constant. I don't know the exact numbers, but let's say they are constant for now. Whatever. And 80. Now, let's say I have a 100 rupees call option. So I know I'll have a payoff of 20, I'll have a payoff of 5, I'll have a payoff of 0. Now, can I say in this case, if I have this particular scenario, the probability is actually payoff into probability. The probability for 20 is Q square, Q into Q, plus for this particular part, the payoff is 5 into NCXP raised to X. So I know two steps, number of up moves is 1. The answer will be 2 of this. So I'll directly write 2. Can I write this is Q into 1 minus Q? And then last one is 0. So I won't write it. E raised to minus 2R. This is using the risk neutral probability approach. Under the state price deflator approach, the equation will actually be 20 into you multiply divided by Q square P square. So Q square P square into e raised to minus 2R plus 5 into 2 into Q into 1 minus Q upon P into 1 minus P into P into 1 minus P e raised to minus 2. So your equation actually becomes 20 into Q square by P square e raised to minus 2R will become AUU P square plus 5 into 2 into P into 1 minus P will be your, so this is now your NCX into AUT. Why AUD? Because Q into 1 minus Q P by P into e raised to minus 2. Understood?
Yes. Yes.
So now essentially the way you create equations is payoff into probability into state price deflator. So I know if for the first one it's all up move, so payoff is 20. For all up moves, your real world probability will be P square and state price deflator will actually be AUU plus payoff into probability of the second outcome is NCX, but now in the case of real world probability. So 2C1 P raised to 1, 1 minus P raised to 2 minus 1 into your state price deflator, which will be now A up move and then down. This is how you write. And you know, AUU is risk neutral probability upon real world probability into PV factor. Similarly, AUD is risk neutral probability upon real world probability into PV. Where risk neutral and real world probability will be based on how many up moves I have, how many down moves I have, so on and so forth. Understood?
Yes. Yes.
Okay. Any doubts, guys? Anyone?
All good, sir.
All perfect. Now let's give this question a try. Try the first question. That's a normal approach. State price deflator is from the second subpart. Try giving a shot to the first subpart first. This is September 2013, question 6. As and when we go on solving sums, in case you all have noted down the list that I had given last lecture, you all can go on striking of the questions we have solved already. Try solving the first sub question. I'll tell you this much. When they're saying an investment in a cash account returns 2% per quarter, they're ideally telling you that I is equal to 2% per annum per quarter. So it is the effective rate of interest per quarter. So it's not per annum, it's 2% per quarter. So it's the effective rate of interest per quarter. Now try to solve.
Compounding quarterly.
Yeah, no, not compounding quarterly. It's the effective rate of interest per quarter. Compounding quarterly would make it nominal rate of interest, which is a per annum rate. So take some time, try solving the first sub question. Now look for the speed in your solving. Till now, whatever we've done, we did it for the concept. In the first sub part, try to solve it quicker so that you establish the habit of solving it faster as well. First, evaluate whether it's a recombining model or a non-recombining model because they haven't said anything per se. Solve it in the next 4 minutes by 7:28. Thank you. It's fine if it's not solved, but just take a stock of how quick you are able to solve.
0.6.
That's the price of the option. If everyone is able to solve it, anyone stuck anywhere?
$28.67.
28.67 is a bit off. I mean, it's close, but it's a big difference. But I think at least what I have calculated. Let's see what others get as well. You're stuck anywhere. Able to solve it, at least taking time is fine. But are you stuck anywhere?
Yes.
Risk neutral probability is 0.6, no?
That is what I said. First, evaluate whether it's a recombining model or a non-recombining model. Yeah, Bhavani, you are also saying something.
I told I am stuck, sir. Like I
Okay.
couldn't.
You are able to construct the binomial tree.
Yes, sir. It is a recombining model.
All right. So 300 goes up to what type? What a value?
330.
Okay.
Up movement is 330 by 300, 1.1. Down movement is 270 by 300, 0.9.
All right. 330 goes up by what value?
360.
Perfect. Comes down by what value?
300.
300.
270 goes up by 300 and comes down by what value?
240.
Perfect. Can you tell me what will be the value of U2?
Sir, after this, like they told it's a 3-step model. So for 3
So-
months they told, right?
Yeah. So now let's see the question. A non-dividend paying stock has a current price of 300, which I'll identify. Over each of the next 2-3 month periods, that means what they are saying is the time value between 300 to this increase is of 3 months. And the time value or the time period between this to this period is 3 months. So they're saying that there are 2-3 months period between this or this entire binomial tree, which actually adds up to a total of a 6-month period. Comfortable till here?
Yes, sir. Yes.
All right. Now let's see. Its price will either go up by 30 pence or down by 30 pence, which is what we do. Price movements for each period are independent. That's fine. And this I told you basically tells that I is equal to 2% per quarter or the effective rate of interest per quarter. Now they're saying a European call option on the stock pays out in 6 months, which is fine for me because I have the entire 6-month binomial model with me based on a strike of 290 pence. So I know K is equal to 290. The price of the stock is to be modeled using a binomial tree approach with 3-month time steps, which I have. I have a 3-month time step at each of the time step, which are a total of 2 time step model. Understood? I know where you got confused, but clear?
Yes, sir.
It's 1.1 is the whole squared, no? It comes from 1.1 into 300 into 1.1 into 1.1. Like that.
What is U2? 360 by 330 is?
One
You count it out.
300 into 1.1 is the whole squared.
Let me divide 260 by 330. It's actually 1.0909. 300 by 330 is not 0.9. That is actually 0.9091. 300 by 270 is not 1.1. It's fairly 1.111. Zero. And 240 by 270 is the answer, not 0.9, but 0.8889. Okay. Now tell me whether it's a recombining model or a non-recombining model.
Non-recombining model.
So you'll have to solve it as of non-recombining. You can't have a single value of Q. Now give it a try. Bhavani, understood what I did over here? U1, D1, U2, D2. Perfect.
Yes, sir.
Now give it a try. So you will ideally have, because it's now a non-recombining model, the value of U and D are actually not constant throughout the tree. You will have Q1, you will have Q2, you will have Q3. Plot your payoffs at each of the three outcomes. You have the probability, bring it one time step back and tell me what is the value of the options. Anyone else got the answer? Ashok, Riya, Manav, Hansraj, Anto, Sania.
I had a doubt in the calculation of R, the risk-free rate.
Okay. Tell me, what's the doubt? What have you done?
I calculated it, like equated it using the, like converted it into delta, but
All right, perfect. So delta is equal to ln of 1 plus I. What's the value of I that you're using?
2%.
All right. What's the value of delta you got?
0.019802.
98026, 3%.
Yes.
Perfect. Now, how will you calculate the value of Q? Rather, let me write Q1 because it's a non-recombining model.
Exponential to the power delta.
Perfect. So e raised to 1.980263. And because I was per quarter, your delta will also be per quarter, which is my time, which is what my time step is. So I don't need to multiply any T over here. Understood?
Yes.
Then you'll have your value of D1 upon U1 minus D. You could have done this as the first approach where you convert from I, you convert to delta, or what you could have done is you could have written Q1 as e raised to R is ideally the accumulation factor, which is equivalent to as good as 1 plus I. So can I say I can also write it as 1 point, or rather, let me write it for you. 1 plus 2% minus D1 upon U1 minus D. Because I know instead of e raised to R, I can write 1 plus I as well. And I know 2% is per quarter. So I can write this as 1 plus 2%. Understood what I did over here?
Yes.
Now give it a try. Let me know, guys, in case you all are stuck anywhere. let me know where you are stuck, what have you done, what's your query. We'll solve it together. I mean, I'll solve that part and then you'll try the further part. At least you'll progress. Shok stuck somewhere.
No. Just try.
How much is the value of Qs that you've gotten?
Actually, I was trying with risk neutral approach. I calculated Q using the Q formula.
Or using the. Acha, you're using the recombining model. But realized why it won't be a recombining model?
No, I didn't get that part.
Take it. The value of U1 D1 is 1.1 and 0.9. The value of U2 D2 is 1.0909 and 0.9091. 1.1 is not ideally equal to 1.0909 because we can't do an approximation over here. I know the values of U and D are not constant throughout my binomial model. Hence, it won't be a recombining model. I'll have to treat it as a non-recombining model. Wherein I solve this node separately, I solve this node separately, and I solve this node separately. So I have U1 D1, U2 D2, U3 D3. I'll have Q1, I'll have Q2, I'll have Q3. I'll have to evaluate this node, bring the value over here. Evaluate this node, bring the value over here. Then these two values, bring it over here. Understood?
Yeah.
All right, give it a shot.
Q1 is coming out to be 0.6 from the
Perfect.
from the second.
Easy.
From the it is coming out to be 0.5963.
That is for which node?
No, like the two approaches we used to find the R.
Achha, from this and this you are saying?
Yeah.
Shouldn't be the case. 1.02 minus D1 is 0.9 upon 1.1 minus 0.9. No, which gives you 0.6 only. 1.02 minus 0.9 upon 1.1 minus 0.9. We're trying from this one, no?
Yeah, from the first one, it's coming out with 0.5963.
Oh, from this one you're saying.
Yeah.
Let's try e raised to 1.98026% minus, I can use ideally this 0.9. Getting 0.6. E raised to 1.980263. This is 3. In case you.
And Q is equal to 0.6 we got.
Sorry?
Q is equal to 0.6 we got. No problem.
I didn't get that, sorry. I heard 0.6, but. I'm getting 0.6 only. When you do e raised to this percent minus 0.9 upon 1.1 minus 0.9, I'm getting 0.6 only on my calculator.
Yeah,
It's 0.6 and then 6 zeros 1/4, but that's 0.6 only.
Okay, I'll check it.
This is the answer I'm getting, which is 0.6 only. I think.
So
Yeah.
Q2 I got as 0.61001.
Q2 will be, which approach are you doing? The first approach or the second approach?
Second one.
Alright, so Q2 ideally for you will be 1.02 minus, you are taking U2 T2 as 0.9091,
Yes, sir.
right? Q2 is 1.0909 minus 0.9091, which will give you How much is it giving you?
0.61001.
Okay, that's fine. Give it one more decimals. No, it's
Okay.
fine. Not take it. All right, that's fine. The probability value seems to be correct.
Q3 is 0.59
0.59.
0001.
अच्छा ठीक है then it's ideally 59 because if it's 0001 till 5 decimals it will come 0 only, so it's 5.
0.61056. 1056.
These are the values of Q. This is Q1. This is Q, or rather, let me write it over here only. Q1 is equal to 0.6. So this will be the value of Q1. This is the value of Q2. This is the value of Q3. A bit different, Hansraj. Let's see if actually it's just the decimal difference or there's a difference. But what's the PV factor that you're multiplying towards the end? In every node?
Sorry, which one?
What's the present value factor that you are multiplying?
What I used at the end was 1 over 1.02 multiplied by the
ठीक है. 1 over 1.02 is fine. So what's the value that you're getting at 330?
1 second. 45.68.
45.68, which is I think fairly fine. What's the value at download?
It's 4.117. 4.118.
So let me see. The payoff over here will be, it's a 290 call option. So here you have your payoff as 70. Here you'll have your payoff 10. Here you'll have your payoff 0. Now, download means 10 and 0. So you'll ideally do 10 into Q3 into 1.02 raised to minus 1. This gives the value and this is 5.78. This is different.
Okay, let me check.
Yeah. Okay, everyone, once you all have calculated the probabilities, plot your payoffs, solve the up node, solve the down node, and then bring it to or solve the original node. And let me know how much you get the value. Let's see that. Anyone got any answers more?
What will be taking R as?
R, which is your rate. If you're using e raised to R, then this. The same way you calculated your Q, that is how you consider. If you want to do 1 plus R, you consider it as 1.02. Understood? Perfect. Let me know, everyone, what value do you get at up node at 330?
Sir,
What?
at upload I'm getting 45.68686.
Okay, that's fine. But
And
the Hansraj also had the same.
See down, I'm getting 5.7843.
Perfect. I have the same answer on my guys. Now bring it, take these two values at your up move, down move and calculate it at time 0.
Yes, sir.
So this, Ansaraj got the reason for difference.
I'm still calculating. I'm getting through all the.
Okay. Let me know if you don't get it, I'll
Yeah.
explain. So now this is C up, this is ideally C down, and C 0, whatever. But that's
29.14301.
the two more decimals is 0, 0.
01.
Okay. We just quickly check. So 45.68 into 0.6 plus 5.7843 into 0.4 into 1.02 raised to the minus 1. Okay, I have 29.1389, which is fair. With 1/4, that much difference is fine. Cool, that's correct. Yeah, someone will probably have somewhere around 1389 or 98, which is also fine.
Yes. So what I got is 29.138941.
Perfect, that's fine. That will be the reason of decimal differences in Q, decimal differences in C up, C and down. That this much difference is fine. All right, everyone take a minute. Understood, but what was the differences? How to solve or how to go about it? Ideally, remember guys, this is right now we are solving, so conceptually understanding its fine speed is secondary, but this was a 3-marker question. So ideally in an examination setup, you should take, yeah, Bhavani, that answer is correct. You should ideally take for this question not more than 4 minutes approximately. Considering it's a non-recombining model, if it would have been a recombining model, then 2.5 minutes. But considering it's a 3-marker question, non-recombining model, somewhere around 4.5 minutes is the ideal time. All right. Let me move to the second subpart. All right. We are done with the first subpart. Now, let's see the second subpart that they're asking. Assume that the real world probability on the stock price of the stock price moving up in each of the next 3-month period is 0.7. Can I say they have actually given me the value of P? What they're saying, assume that the real world probability, so I know the value of P is 0.7. I know the value of Q1 is 0.6. I know the value of Q2 is 0.61001 and the value of Q3 is 0.59. Now let's say what they're asking. Calculate the values of the state price deflator after 6 months. Hence, can I say they are essentially asking me to calculate if I have this diagram. Let me write movement. Let me write state price deflator. Can I say they are first asking me to calculate the state price deflator at each of the nodes? What are the movements that I have? The first movement is U1, U2. The second movement is U1, D2. The third movement is D1, U2 or D1, U3 rather. And the last movement will be all two down moves, which is D1, D3. So what I've done is I've written all possible paths. You can have up move, down move, down move, up move, down move, down move. That's all possible movement that I have. The state price deflator, can I say is A, U1, U2? A U1 D2, A D1 U3, and A D1 D3. Now I know the equations or the state price deflator is risk neutral upon real world into PV factor. Can I say risk neutral for U1, U2 because my Qs are different is actually Q1 by Q2 upon real world will be P into P into let's say I solve it using this. So 1.02 raised to minus 2 by minus 2 because I'm doing it for the two time steps together. Similarly, U1 D2 will be Q1. D2 is actually 1 minus Q2 upon same way, but for real world probability into PV factor. A D1 U3. D1 is actually 1 minus Q1. Q3, the probability is Q3 upon 1 minus P into P into 1.02 raised to. Everyone's understanding what I'm trying to do over here? Priya, Hansraj, Ashok, Manav, Anto, Sanya, Tom.
Yes.
Yes.
Perfect. Now I know A D1, D3. The probability of getting D1 is 1 minus Q1. Probability of getting D3 is 1 minus Q3 upon. Same way for real world. I know two downmost, which is 1 minus P, 1 minus P. And the PU factor is 1.02 x to minus 2. Let me know what answers you get for each of them. You have the values of, I'll just write it down. The values of Q1 is 0.6. Value of Q2 was 0.61001. 61001. Value of Q3 is 0.59 and the value of P is 0.7. So now from 0.7. Yeah, 0.7. Let me know what you get the values for each of the state price deflators. So this is how you do the state price deflator approach. Determine the movement, calculate the state price deflator. Now we'll see how do we calculate the values. Start practicing the chapter, guys. We'll do a few questions today. From today, start practicing this chapter. Do the questions that I have given as part of the list. You all will get comfortable with the questions. Anyone got the answers? Thanks, Ria. 0.71797. Ria 1.07. We write it up clearly. 0.717947. 1.070964. 1.0801706. And finally 1.75146312. Perfect. Take a minute, everyone, solving. All right. Thanks for me. Now let's see the next subpart. I'm done with the first subpart. They told me to calculate the values of state price deflator. I gave them the values of the state price deflator. Now in the second subpart, they are asking me calculate the value of the same call option using your answers to part 2A. Essentially, now I know they are saying calculate it using state price deflator. So I know the formula under real world probability or the state price deflator approach is payoff into probability into state price deflator. So I have my state price deflator with me. Let's plot the payoffs that I know already, but let's put it in the form of a table. I know if both the up moves happen, the payoff is 70. If one up move, one down move, payoff is 10. Same, payoff is 10. And finally, in both down moves, the payoff is 0. This is something that I've already plotted. So I have my payoff also with me. I have my payoff, I have my state price deflator. What am I left with is probability. Under real world probability or under state price deflator approach, I know the probabilities are actually real world probabilities. They are not risk neutral probabilities. So can I say for both up moves, the probability will actually be P square. For one up move, one down move, probability will be P into 1 minus P. One down move, one up move, probability will be 1 minus P into P. And for both down moves, the probability will be 1 minus P square. You know the value of P is 0.7. Calculate your real world probabilities. Once you have the probability, you have your payoff, you have your probability, you have the state price deflator. Create a column with payoff into probability into state price deflator and add it all together. Tell me the values of probability. If you want, tell me the final value directly, the summation. Oh, 9.14, so perfect. And that is what you actually expected as well, because your price under risk neutral was actually 29.14. 29.14301176. Everyone who's solve. Ria, you can think about the next theory question. This is fine. This they are just saying compare. So the answer that you write is the answer is both same in both the cases because ideally it's the same approach. Now what they're saying is assume that the real world probability has dropped from 0.7 to 0.6. Comment on the impact that this would have on the option price. This part leave 3B. So now what they're, I'll go to that screen and I'll actually tell you. Now what they're saying is that the real world probability has changed from 0.7 to 0.6. Explain, you don't need to solve it because they are not asking it mathematically, but explain what would be the impact on the option price. Perfect. That's correct, Bhavani. That's more or less approximately equal to risk to input. That's correct. Take a minute, I'll actually discuss it with everyone. Paper 5. All. Now what they're saying in the next part is once you've gotten the real world answer, you know as part of C, the value that you had gotten in part 1 and the value that you're getting in part 2B are the same. May it be risk neutral, may it be state price deflator, the answer is coming out approximately to the same. That is what your answer will be to part C. Now what they're saying is, assume that the real world probability has now dropped from 0.7 to 0.6. So now they are saying that the value of P from 0.7 has actually gone down to 0.6. Comment on the impact that this would have on the option price. I think Ashok had answered this when I had asked last lecture. But what would be the impact on the option price if the real world probability goes from 0.7 to 0.6? Remember, you don't have to do any calculation because it's a 2-marker question. 1 mark for this, 1 mark for this. Any thoughts? Take care. How did we introduce real world probability into the equation? Okay, let's go back to the steel price deflator derivation. The way we introduced P is by multiplying and dividing by the same factor. We introduced 1 minus P by multiplying and dividing by the same factor. Even if P from 0.7 goes to 0.6, I know at an option price level, when I'm calculating the price of the option, essentially it's getting cancelled out each other. What will change is the value of this column will change and the value of this column will change. But both of them will change in such a way that this column and this number will not change. Because both of them will ideally nullify each other when you are increasing and decreasing at both the parts. In this case, you are changing your denominator. But in this case, you are then essentially changing your numerator as well. So essentially, both will cancel each other out and hence, you won't have a change in the final option price. Because you are multiplying and dividing by the same factor, same value of real world probability P. Everyone understood? Everyone else? Thanks, Ashok. Perfect. All right. Good question.
Yes, sir.
Yeah.
Oh,
Only confusing part is that they give 3P upwards and downwards, right? So we were trying to do in combining model. So
three step. That's the trick. So there were two tricks in the question. One was the R being given as a effective rate of interest, not the force of interest, and the other was they gave it converging, but it's ideally a non-recombining. Take it. Let's try subpart 1 and subpart 2 over here first. Actually, I can try some part 3 as well. We've done a similar question. So this is April 2010 question 3, CT8 obviously. Read it. I want you all to figure out what it is so that even if you all make an error, you all realize what's the error and be attentive about it. Try solving 1A, B, and 2. 1A, we've done. What is the condition for no arbitrage?
E raised to R is between D and U.
Perfect. D e raised to R U. Now, what you need to remember is first also look at what is the definition of R. Is it effective? Is it compounding? Is it continuous? Whatever. If you all are comfortable, use 1 plus I. If not, convert it to delta and then use e raised to R or e raised to delta. The way we did it in the previous question. Now give it a try. 25 point, that's the final value.
Part 2.
25.009534. Let's see if anyone has any other question. Was this correct? Was this true? I mean, they've written proof, so it has to be true. Alright, so it was ideally 0.8.
I mean, simply we can calculate it e power r and prove, right? Because u, d we have values.
Exactly. So e raised to 5% less than 1.2. And this ideally will be true itself because they've written
e power r is 1.05 127 something.
sense. Easiest one mark of the paper.
Yeah, we will get this question in the exams.
And I have asked this almost in all the questions, by the way.
Oh.
Then let's construct the binomial tree. So it starts at 100, goes up to Bhavani.
Yeah, combining model it is.
In the no arbitrage, like it is a compound risk tree. So should we take the RS delta and prove, because both are
Yeah, because if you see they've written over here. So because they've written continuously compounded risk-free rate, it will be delta.
Oh.
If they would have written effective compounded risk-free rate, then it's ideally I. So you'll have to compute delta there.
So it proving this also we have to use delta or only R. Anything?
Yeah. You need to use e raised to. Otherwise, what you could have done is, let's say hypothetically 5% would have been I. You would have wrote this as 1.05. Understood? Or wherever, if it's I, your e raised to r becomes 1 plus I, or you calculate the delta value and then use it as a e raised to delta itself. Alright. Can someone tell me the binomial tree? The current price is 100, U is 1.2, D is 0.8. It's a 2-period binomial.
Yeah,
So 100.
120, 80.
Perfect. 120, 80.
144, 96.
144, 96. We'll go to
96 and
96.
76.8.
76.8.
Yes.
Now,
Q.
76.8.
Correct. Mm-hmm. 80, sorry, 80%. 64, 64. Sorry, 64.
Alright. I have a binomial tree, so I'm done with 1A, I'm done with 1B. Now let's see 2. Calculate the price of a standard European call option written on the stock price with K as 100 and maturity 1 year. So I know they're talking about this because over each of the 6-month period, so this is 6 months and this is 6 months, which is fine my option to be a 1-year period. K is 100. What's the value of Q that you are getting? E raised to R minus B or numerized. Take some time, solve it. The reason and it is Ria, the answer is a bit different. What's the value of Q that you're getting?
0.628177.
Yeah, same.
0.628177.
Right.
Take it. What's the payoff at 144?
44. 44 is the payoff. 44 multiplied with Q.
Now,
Okay. Probability and
26.3 is the
value of Q. Please try e raised to 5% minus sorry.
You series to 5%. So will that be a thing? I used 1.05.
1 plus I. So you'll use 1.05.
Yes, sir.
1.05 minus take it. Over each of the 6-month period. No, why did you use 1.05? in this, that was the hypothetical scenario. In this question, they've said it's the continuously compounded risk-free rate. So in this question, you will use this as delta itself. Hypothetically, we would have written that this is the effective rate of interest, then we would have written it as 1.0. Understood?
What is the answer? 25?
How much are you getting?
I have 25.009. Is it so?
5.009.
Because there is only one payoff, 44. No.
Okay, I know what error you are making. No. Even if 009. What's the formula that you all are using? Acha, I got it. So the way you all are, the formula that you're using is 44 into 0.628177 into e raised to minus 5% into 2. Correct?
2. Yeah, that's what I did.
Check. I'm assuming, Ria, you've done the same thing because you have the same answer. Alright, let's see if someone else has any different answer. I'll tell you all this much, there's an error in this equation. Think about whether you're
There will be Q square.
exact.
I did Q square.
What's the answer that you are getting now?
I'll the calculations.
Because it's payoff into probability, or probability is actually Q square, not only for one time step.
Yeah, got it.
I think I got 15.72, but
15.74.
15.710.
All right. 15.7104367. That's fine. I believe this is perfect.
because the first, sorry, the first
Yeah,
one was
got it.
till only the first part till 6 months, but then we have to put it back till times 0.
All right.
So that's why it's
So
15.724.
how's the value that you're getting is 15.74?
So instead of using only one Q, like we have to use like 2 Qs, right, to multiply it.
Which is
So
what we've done Q
0.6.
square.
Yeah, exactly. 0.6 to the whole square. Yes.
Perfect. Well, what's the decimals that you're using? All right, let me see what's the accuracy that I'm getting. 7, 2 e raised to minus 5% into 2. Why do you have 724? What's the accuracy of Q that you all are using?
So mine is 0.628178.
7.8.
Yeah.
Even then, I have 15.7104517. So it's 7104 only.
Okay.
Just see if this, even if you use 628178, you'll have 44 into 0.628178 square into exponential minus 5% into 2.
Okay. Yeah. 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 I think you're right. Yes. I made a mistake. Yes.
All right. Any doubts, guys, in this subpart? Comfortable, everyone? All right. Now try reading the third subpart. It's a similar question to what we've done when we were doing the chapter. Try reading the third subpart. calculator is there. So it's not the question was take not that difficult. Think about it and then give it a shot. First, let me know the payoff, then go ahead. What do you get the payoffs in? How many states and what are the values of the payoffs? Let's create a let's read it together. Consider a special type of call option with strike price K is equal to 100. I know the strike is 100 still and maturity 1 year. So I know the time period still holds. The underlying asset for this special option is the average price of the stock over 1 year calculated as the average of the price at time 0, 0.5 and 1. So now they are saying that the strike price is K, but the other value to compare against is not the maturity ST, but the average ST of 0, 0.5 and 1. Calculate the initial price of this call option, assuming it can be exercised only at time 1. That means it's like a European option. At time 1, you will take the average of the stock prices of the path that I've followed. You will compare with the strike price, and it's a call option, so it will be average minus K. Let me know first, how will you calculate the averages and what is the value of the payoff? Let me take it near the diagram.
So for the first up node, we will take all the three values of the up node.
Perfect. So if we are saying all three up moves, that means the path that I followed. Yeah. If you are taking all three up moves, that means the path that I followed is this. So you take the average of 100, 120 and 144.
So the payoff is 21.33.
How much?
21.33 payoff.
That's the payoff. Take it. Fair. Perfect. That's correct. Similarly, do it for all possible paths. So you'll have up, up, you have up, down. You will have down, up as well differently, because up, down will give you a different average than down, up. So you'll have to evaluate both separately. This is the movement. You will have the average. So I'm assuming this is 123, 21%. So this is 131.33. payoff, just 21. So price is 8.74. Yeah, looks fine. 8.74244. The next column that we'll have will be a probability. Will they pay off into probability? All of them up, and then multiply that by e raised to minus 4.5%. This will be this. What's the payoff in the other cases?
5.33 and 0.
Uh, 0, 0. So this will be around 5.33. What's the average in the other two conditions?
92, 81.33.
Perfect. This should give me somewhere around 8.74. Also for the past papers, guys, I've already had a word. We are working around to get a workaround. Uh, give the team a few days. They are trying to set something up. It'll be a temporary solution, at least for your early work through. For all subsequent semesters, we are trying to find a sustainable and a long-term solution. But in the interim, they're just setting something up so that you all can access it. Let me know once you're done. 744. All right, that's four flows are also very high for at least 326. All right, that's correct. This was, by the way, April 2010, question 3. Take a minute, everyone. Sorry. Done? Everyone?
Yeah, done.
Uh, let's go. We'll be able to solve. Let's try this one. This is September 2012, question 2. Think it will be able to. Yeah, okay. Let's try this. Which one sounds better? Okay, solve this one. Thousand 12 question 2. Remember your increase decrease they've given you. So you don't have to apply your minds to.
There will be 3 time steps.
3 times steps. Let's see the question together. A non-dividend paying stock has a current price of 400 pence. So I know the model is currently starting at. Should I solve it down? Let me solve it down. Take the question down. All right. Now, a non-dividend paying stock has a current price of 400 pence. So I know it's starting at 400. Over each of the next 3 years. Now they're saying over each of the next 3 years. That means the time period is yearly and there are a total of 3 years. So as you said correctly, it's a 3-step binomial model. Its price could increase by 20%. That means in the next year, it can either go up to 1.2 ST or decrease by 20%. What we were generally doing is we are taking 80%. So we are taking 0.8. In this question, they are saying you that don't take it as 0.8, take it as ST divided by 1.2. So it's ideally like your U is equal to 1 by 2 as the assumption that we had taken in the full normal model. U is 1.2, D is actually 1 upon 1.2. So your 400 will go up by 400 into 1.2 because that is the level of increase, which will give you what? 480. 480. Yeah, 480. Which will give you 480. or it can come down to 400 divided by 1.2. Understood why divided by 1.2?
Yeah. It was 333.333.
Now remember, I'll tell you all this beforehand. When you look at the IFO solution, IFO has mentioned that for students who took the value of U as 1.2 and took the value of D as 0.8, they've given full credible marks for this question. Even if instead of taking it as divided by 1.2, you all did it originally like we do. Decrease by 20%, that means D is equal to 0.8 and multiply 0.8, even that is given full credible marks. In this specific scenario where IFO took it, ideally they wouldn't have given because they have mentioned it in the question in brackets. If they wouldn't have written this, then you take 0.8, there's absolutely no issue with that. But if they've written in brackets, then there's an ambiguity that comes in, then why did you take 0.8? Understood? All right, now tell me the entire tree. 480 goes up to
576. 480 divided by 1.2. 400.
400. You come over here.
1.2. 400.
177.
177.
277.775.
200, sorry, 277, 177. 277.77, and we'll need one more time step.
691.2.
691.2. This will be 480 only. Check it back.
Yeah, 480.
Yeah, so remember in this, when U is equal to 1 by the assumption holds true, the middle values converge to the same value. This will be 480. This will be 333.33. This will go up, and let me know what this will.
231.475.
Perfect. Thank you. You want to copy it down. Copy it down. Let us solve it together. Done. I'll go ahead. All right. Now let's see what they're asking. The continuously, they've told me the word continuously. I know it means delta. The continuously compounded risk-free rate is 6% per annum. That means I can very comfortably use e raised to 6% throughout my question, or e raised to minus 6%. The stock price move in each year is independent of the move in other years. That's fine. Now let's read the further part that they are saying. A non-standard derivative, that means it's not a plain vanilla call, it's not a plain vanilla put. They are saying a non-standard derivative pays off root of S3 after 3 years. That means my payoff is actually coming in at time 3 only. It's behaving like a European. I don't have to look at any of the intermediate value. I have to look at maturity only, where they are saying the payoff is actually root of S3. What do I mean by S3? This is ideally S0. This is S1, this is S2, this is S3. They are saying you will get the payoff, which will be square root of these values. But let's say when we'll get the payoff, even there has to be a condition for that, provided that at some point over 3 years, remember they've said at some point over 3 years, The stock price has moved up in 1 year and then immediately down in the following year. Let's read it again. A non-standard derivative pays of root of S3 after 3 years, provided that at some point over 3 years, the stock price has moved up in 1 year and then immediately down in the following year. The words important being immediately in the following year, otherwise the derivative pays 0. That means, can I say, I need to, if I plot my movement in a table, what all are the possible movements I have? All up moves, which is up, up, up. I'll have up, up, down, which is up, up, down. Similarly, I'll have U, D, U. What else do I have? U, D, D. I'll have D, U, U. I'll have D, U, D. Anything else? U, U, all D, D, D also will have. U, 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 D, U, D, 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 D. Then I have U, D, 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 U, U, D, D, U I have missed. I'll have D, D, U and I'll have D, D, D. Again, all three up moves. Then I'll have one down move. So U, U, D, U, D, U, D, U, U. If I want, let's actually write it that way. It'll make life easier. So first, I want to write the movement. So I know the first movement is all three up moves. So I wrote U, U, U. Then I have one down move. That down move can be anywhere. It can be U, U, D. It can be U, D, U. Or it can be D, U, U. It can be at any place. Then I have two down moves. So again, it can be U, D, D. Or it can be D, D, U. Or it can be D, U, D. At any places, I can have two down moves. And then the only possibility is three down moves. So that's how you can frame your entire move. Alright, copy this down. Let's put the spot also beside. So let's write S3. If all three up moves, I know the spot price is 691.2. If two up moves and one down move, it's 480. Up move, down move, up move. I know it's 480. Down move, up move, up move. I know it's 480. In two down moves, I know the S3 is 333.33. 333.33. 333.33. And finally, in all three down moves, you've correctly told me it's 231.475. So question. Just a second. Let's put the 2012 question. Cool. Copy this down. Let me know once done. Done? All right. Now let's read the question again. When will I get the payoff? At some point over 3 years, the stock price has moved up in 1 year and then it has immediately moved down in the following year. That means, can I say I'm looking for the pattern wherein U and D are coming together in that order? Because it's going up and then it has to go down in the following year. I know U, I don't have. So the payoff will be 0. UUD, all right, I have UD over here. Hence, can I say the payoff over here is actually root of 480? Because they've said if it comes, it's root of S3. UDU, I can see UD again over here. So I know the payoff will be 480. DUU, I don't have UD over here. Hence, I know the payoff will be 0. UDD, I can see a UD. So root of 333.33. Nothing over here. I can see a DUD over here. So root of 333.33 and all three downwards. No payoff. Understood? How did we determine the payoffs? Once you get the payoff, you have your difficult part done. Now you create one more column of probability. Do it only for the ones where you have a non-zero payoff. No, not required to do where you have a 0 payoff. Get your payoff, get your probability, do payoff into probability, and then multiply by the PV factor. It's a 3-step binomial model, so e raised to minus 6% into 3.
What will we take D as in this equation?
Sorry,
What will we take the value of D?
the value of P,
D.
the value of D, it will be 1 upon 1.2. Because U is 1.2. So D will be 1 upon 1.2. In this question, because they've said that ST plus 1 is equal to ST divided by 1.2. If this wouldn't be there, then ideally D would have been 0.8, the way we used to do it. Let me know what is the value of Q also that is calculated. Perfect. 0.6231. No need to calculate the payoff into probability for these. Zero 54731. That's correct. Yeah. We just put in the snapshot of IFO comments as well. Just to set purpose. Right. Got the answer, everyone? Alright. Let's just read the comments as well that IFO is putting out. Let's see. So, just consider. Let me just refresh it once. Otherwise, nothing that I write now. Let's see. Let me just add the. So this is the as you all know, IFO adds comments after every question. Let's just see what are the IFO comments for this question. They are saying if candidates work in units of pounds rather than pence. So instead of taking 200 pence or 100 pence, if you take 1 pound, even that's correct. But it's perfectly fine. This should ideally be 8.0, 8.5 only. It's ideally correct only even if you solve it in pence. Solve it in pence only. Don't get into rupee, paisa, pounds, pence, pounds issue. Solve it as they've given. Also, if candidates took a down movement of 0.8 rather than 1 upon 1.2, full marks were available in that case. So perfect. Even if you would have solved D as 0.8 and U as 1.2, that would have worked. Largely well answered. Some candidates didn't calculate the price correctly because they miscalculated the number of paths to the nodes with non-zero payouts. What they are saying is they were not able to identify all of these paths correctly. And if they were able to identify, they were not able to identify where all will I have a payoff. So they didn't identify that wherever U and D comes together, that is where the payoff will comes up. That is where the payoff will come. Some candidates miscalculated the probability by using e raised to minus r rather than e raised to r. So your q is equal to e raised to r minus d upon u minus d. Some candidates wrote the formula as e raised to minus r minus d upon u minus d instead of e raised to positive r. A few candidates calculated the probability according to the classical probability theory rather than risk neutral. So they actually saw how many ever times it going up. It's ideally real world ke hisab se they saw rather than the formula approach that's there, which is fine. Any questions? Good sum. This was an 8-marker question, by the way. Yeah, 8-marker question. Fairly straightforward. More number of marks are there is because there are more technicalities and more variations that they've asked over here. Just note these 2 questions as down as well that all can give a try. You all, as it is, have the entire list of questions on OneNote. I've solved in the sheet sum solving in class. The sum sheet has a list of all possible questions that I had for this chapter till 2020 or 2018. After that, you'll have a fresh number of sums as well. You all can get started with those sums. You all can get started with the practice questions. Unit 1, you all can solve entirely. Start practicing. Get this chapter out of the way because now when all will do more chapters, you all are in parallel with the solving as well. As it is, our next lecture is now directly on Saturday. If I'm not wrong, Saturday. We'll start with Greeks on Saturday. In the interim, let me know if you all have any questions from this chapter or the previous chapter. If your assignment happens, whenever it happens, these 2 chapters will be there at least. If Greeks will finish on Saturday, then ideally Greeks will also be there because I haven't received the notice of your assignments yet. Taking your attendance and share that screen. Started at 7. 34 lectures. Chapter 2. Was today's lecture helpful? I mean, do you all want me to do this after every chapter?
Yeah,
Yes.
today it's really helpful actually.
Yes, sir.
I
Yes.
mean, now we get a clear clarity on how to solve the questions.
Right. Take care. Bhavani present, Hansraj present, Ashok present, Riya present, Tom present, Agto present, Sanya present, Mana present. 1, 2, 3, 4, 5, 6, 7, 8.
I am present, yes, sir. I am present.
Yeah,
Now.
done. Yep. Cool, guys. Thank you. I'll see you all on Saturday.
Thank you, sir.
Thank you.